there are four pillars of object-oriented programming. They are abstraction, encapsulation. They generally go hand in hand, so I generally put them together. Then next is polymorphism, and the last is inheritance. Now, if you study the structured programming more closely, you will find out that al almost all of these, they were available through one or the other construct of the structured programming language as well. So everything that a C++ program can do, a C program can also do using some pointer manipulation and some things like that. We are not going to talk about that today. Uh, we're only going to focus on inheritance. So inheritance is a chain of multiple classes. There's going to be a parent class. The parent class is going to have certain properties, and then there's going to be a child class, and these child classes, they are going to inherit part of the functionality from the parent class. Now, I myself, I'm not a very big fan of inheritance, and there are very few places where I have actually gone ahead and created parent and child relationship. But then, because this is important from the discussion point, I'm going to try and explain what the concept actually is. So the parent, it is first of all drawn like this with an arrow, an empty triangle pointing towards the parent. The parent is going to have members, it's going to have properties, and it is going to have functions and methods inside it. Right? These members, they can have an access specifier. So there are 5 type of access specifiers. Let's go ahead and write them down over here. So there's one specifier which is private. Next is protected, public. In C# there is a new access specifier which is called internal, and there is something called private protected, and probably there are a couple of other combinations as well. I have mostly used these four. I have never used private protected and other combinations. So what happens is, during inheritance, if I have a member variable over here with the parent, say I don't know what happened. Alright, so with the member I, the child can either inherit this or cannot inherit this based on what access specifier is specified. So private properties, they are not going to get inherited. It has to be protected or public, and then I think there is one more which is protected internal or internal protected. Right? As long as there is protected or public, the properties are going to get is going to be available inside the child as well. But then it has to be in one of these categories or a combination of these categories. Internal is more specific to the assembly. So the curly braces that we saw in IS5 yesterday, which indicates an assembly, it generally means an exe or a DLL file. It can also mean a namespace. So when we declare a variable internal, it is accessible within that same namespace. So if you are replicating the same namespace in multiple places, the variables, the classes, the functions that are modified with this access specifier, they'll be accessible in those namespaces as well. But then in relation to inheritance, only 3 keywords matter, 3 access specifiers. One is private, second is protected, and third is public. Now, C++ had multiple combinations of changing the access specifier in the child, but then C# does not allow that. So a parent class might look like this: class parent, and then I'm going to have private I, protected J, and public K, for example. And if I can create a child class, I'll have to put the colon sign here, and I'm going to mention parent. Now with this colon sign, the parent-child relationship is established. One thing that I should tell you at this point is, when the right side of the colon sign is a class, alright, only then it is inheritance. Okay, so you have to be very careful with the word that you're using. If it's a class, then it is inheritance. If it is something else, it is not inheritance. And as we see examples of interfaces, I'm going to explain more things to you. Now, because there is a parent-child relationship, I can create a function here, say print, and inside print or other functions, I will only have access to these two variables, j and k. Right? The private variable I will not be accessible to me in the child class. Make sense? Uh, there could be multiple other classes like class parent2, right? And it can have its own code. I cannot have multiple inheritance in C Sharp at least. Other programming languages like C++, they allow it, but then C Sharp does not allow it. So we don't have this option. So there will be only one parent, and I'm going to table the rest of the discussion until we talk about interfaces. But this is the brief introduction um, to parent and child and inheritance hierarchy. If there are functions inside the parent class, they are going to have similar similar rules. So I can have a function over here called log, for example. Right? This log is going to be visible inside child. Now, the way we are going to use it is, so I can declare an object of parent like this, parent be assigned to new parent, and I can access only the public variable outside. So I can use public p.k and I can assign value to it. Okay. When I create an object of child, c assigned to new child like this, I can access the public members of k over here, and it'll still be accessible. Child can have its own set of variables, and as long as they are public and accessible outside, I can have statement like this as well. Right? So if I'm using a reference of the child class, I can access everything that is available through the parent and through the child. But let's look at the next statement here. If I declare something like parent key and I assign new child to it, okay, even though this is the child object, I will only have access to the property k, because the reference that I'm holding is coming from the parent class. It is the reference that influences which members you can access. If you have a reference of the parent class, you're only going to have access to the parent members. Okay. The other way around of inheritance is allowed. So I can have another class over here, public child2 and parent, and I can have its own members over here. And once again, it's going to be the same rules. Whatever is accessible through the parent j and k is accessible inside the class. Outside the class, I can replace this child with child2, and I will once again have the same rules that because I'm using an object of the parent reference, I will only have access to the members through the parent. Okay, I will not be able to call functions of child2. So these are some simple rules of inheritance. Let's go ahead and see it in action. I'm going to add a new class, inheritance demo. Right. Let's go ahead and declare those classes. Class parent, and we're going to declare one variable each: private integer I, predicted integer j, and public integer k, like this. And let's define a child and I'm going to read this as inherits from the parent, and I'm going to declare a public integer x over here. Now if I, and this is where the var keyword is going to become very significant. So let's see an example of parent first. I can declare the parent here like this and initialize. I will not be able to initialize these members. So let's go ahead and create a constructor. The short key for creating constructor is you type ctor and hit the tab key twice. It is going to create a constructor. A constructor has the same name as parent. It looks like a function, but it does not have a return type. And it is going to have, if you want it to be accessible outside, you can leave it public. So with this parent object defined, if I now type p dot k, it is only k that is accessible outside. If I run it, I'm going to see 30. So I and j were initialized, they were just not accessible from the outside. Now let's go ahead and create an object of child. Once again, I'm going to say var child new child, and now I can type child dot k. Notice that k is available over here, and then this is a nice tooltip. It is saying that it's a field, it is of type integer, and it is coming from the parent class parent dot k. If I select x, it is coming from integer child dot x. So let's go ahead and print those values, and I'm going to define a constructor for the child as well, and to x I'm going to assign says 100. And now if I run this application, the first 30 is for parent, the second 30 and 100, they are k and x variable of the child class. Now there will be scenarios where you would want to influence the values of the parent constructor. The parent constructor at the moment is not giving us much option, so this time we are going to create another constructor, and we're going to take the same values, integer j, integer k, like this. And because there's some name overlap, I can introduce a this keyword to you now. So this refers to the object that we are dealing with. And I'm going to change this to j, this to k, and alright, this I, j, and k is referring to the parameters that we are receiving, and this I, j, and k, they are referring to the current instance of the parent class. This keyword is going to point to the current object. Now, if I want to call this constructor, if I want to call it from here, I just have to pass these values and nothing changes because these are the same values that we are assigning here as well. But then it is going to invoke this particular constructor. If I want the child to call the parent constructor, I have to type base over here, and then I can influence those values. So it is going to assign 50 to I, j, and k, and x is going to be 100. And now if we see the output, it is going to print 30 for k, it is going to print 50 for k, and it's going to print 100 for x. So 30, 50, and 100. So this is the inheritance hierarchy that a child can choose which constructor of the parent class it wants to call by passing these arguments. This is going to come in very handy when we look at entity framework and we are creating object for our MVC solutions. Right. So far we have been looking at the parent class object and the child class object. Now let's see a third example of this, that I'm going to declare child object. I'm going to call it new child, and I'm going to assign it child object. Now if I hover over the var keyword, it is going to say that it is the child object, but I can also assign the child object to the reference of a parent class. The only problem is I will lose access to the X member here. Now if I do new child dot, I only see K. I don't see X here. And that is because the reference that we are using is coming from the parent class. And that's why you should be very careful when you're using the var keyword. Var keyword is going to abstract out what object it is creating. It is going to pick up whatever is on the right side. Right? If you want to be very specific as to what type of object you want to create, you would want to specify it with um, with the static typing. Okay, don't leave it to var. Var is going to pick up the type from the right side. And now if I run it, it's going to print 50. No surprises there because it is calling this constructor for creating child first, and when it gets here, it is passing 50 for k, and that's how k is getting initialized to 5 to 50. I can duplicate this class and showcase a couple more concepts. Like I'm changing it to child 2. Once I change it to child 2, I have to change this constructor as well. And I'm going to initialize these to say a series of 80s. And I'm going to change this variable here to y. And this y becomes say 200. Now if I come over here, let's go ahead, create an object of parent, call it b, and assign new child 2 to it, and print the value. Once again, we don't have access to y, even if it is object of child 2. It is going to print 80 as a last output, right? Because we are passing a series of 80s through the child 2 constructor. So when child 2 invokes base, it is passing 80, and that's what we are seeing here. Now I can assign it a new child like this, and that statement is going to work just fine. The thing is, once you have a parent reference, it can switch between all the children for that particular parent. So if they match the inheritance hierarchy, they're going to work just fine. And then the last line that we are seeing 50 is from child 1, and the 80 above is from child 2. So the parent reference can point to multiple references of different child classes. Let's go ahead and try it a little differently. Can I have an object of child, say child C, and assign it new parent? And then this is going to complain. It's saying that it cannot implicitly convert a parent to a child, right? Because if I try to access C, C is going to give me access to K and X, and the parent has absolutely no clue about what X is. X is specific to child. So the inheritance only works from the parent reference to the child reference and not the other way around. And if you remember this concept, let me pull up IELTS one more time and search for func. So I told you to ignore this particular value here, in, and out. So the concept of generics is called covariance, contravariance, and invariance. The type of generic that we have seen with the swap function, we did not have anything different mentioned here. When we don't mention anything, we cannot play around with the type. Once we pass integer, it is an integer. With covariance, the input can be more specific. So we can pass a parent object to a child class. Let's go ahead and see the last example of inheritance, and that is for functions. So I'm going to come here again, and I'm going to define a protected function. It's going to get called protected void, and I'm going to call logging. And okay, I did not realize I'm in the child class. Let's do this in the parent class, and over here I'm going to type parent, and then this double colon is access specifier, and after that you generally mention the function name. So I'm going to say that I'm in the log function of the parent class. Now if I pick up any of these child, let's just comment out most of this code. And now if I do p dot child dot log, Okay, because log is predicted, it is not accessible outside. Let's go ahead and change the, let me show you another function, public integer. I'm going to call it invoke. The protected members, they can be invoked from within, okay, I'm going to call it void, public void invoke, and I can invoke the protected members of the parent from the child class. Right? They are not accessible outside, but they are accessible in the child class itself. And now if I do child.invoke, child.invoke is going to come to this line, and it is going to invoke the log function from the parent even if it is protected. And it is going to print parent log, right? Now, protected can be inherited by the child class. So if I want to inherit, all I have to do is type log over here, and if I hit, okay, I was hoping for something else. If I type protected void log and give a different version of log, something more specific to the child, I'm going to say child log. Alright, notice that this green is squiggly under it, and it is saying that child.log, it hides the parent implementation. So let's first see, okay, because these are protected, they are going to cause some issue, but then protected members can get access through the invoke function. We are going to leave this code as is. The invoke function is going to get called, and now we have two implementation of log. One is for the parent, one is for the child, and we saw that green squiggly error message. When we run our application, it is going to say child : log, and that was the warning message that we read, that this log here, it hides the implementation of the parent. When you don't want to hide, when you don't want to have such warning messages, there are special keywords that you can add. One such keyword is virtual. When you mark something virtual, you are indicating that these functions, they can be inherited or overridden in the child class. But then because you want to avoid accidental override, you are going to add another keyword over here, which is override. So with this override, the green squiggly has disappeared and there's no warning now. Now we are very sure that we are overriding this particular implementation. And then we had already indicated that this is going to be a virtual function. Now if I hit Control F5, there is no change in the output. We are still calling the log function of the child, but then that warning has kind of disappeared and the confusion has kind of has disappeared as well. Now I'm going to switch to another implementation. I'm going to use this. I'm going to create the object of the parent, and on this parent, you know what? I'm going to switch to child1, not child2, because we don't have invoke and log function there. And then over here, I wanted to show you an example of calling the log function using the parent reference. So let's go ahead and remove the protected. I think protected has kind of helped us already. Notice that you cannot have different access specifier at different level. So the parent class is specifying log with the protected keyword, and then in the child I'm using the public function and the public access specifier, and it is complaining about that. It is saying that you cannot change the access modifiers. Alright, protected has to be protected. So either I'll have to change this to protected or switch this to public. Now when I do this and invoke the log function using the reference of the parent, let's see what happens. I'm going to comment out this code. There's only one log function that is going to get called. Alright, so this is different than what we saw in the members. Right? When we were having the reference of the parent object, we were only able to access what was available through the parent. But with the virtual keyword, things got a little tricky. The virtual keyword says that if the child overrides it with the override keyword, and we are still using an object with the reference of the parent, the parent will be able to call the child implementation. Right? And if you have studied C++, there are two types of polymorphism. One is called static polymorphism, and the second is called dynamic polymorphism. In static polymorphism, the binding happens when we compile. So at compile time, our exe knows which function is going to get called. But dynamic polymorphism is a runtime concept. At runtime, depending on what object is assigned to the P class, the parent member, it is going to decide which function to invoke. And then if you are following the session up until now, runtime polymorphism is an implementation of function pointer, right? Depending on where this function is pointing, child1.log or child2.log, the function pointer, if we invoke that, the correct implementation is going to get called. And then all the parent is referencing is the log function. All right, and that's why when somebody says that inheritance and polymorphism, inheritance is not available in C programming, they are not entirely correct. C has a programming language feature called function pointer, and through function pointers, we can change which implementation to be called at runtime using function pointers. And then if we are doing that, C++ or object-oriented programmings, they are not doing anything different. They are also calling, they are also calling implementation based on what object is getting assigned where. It is just that C is giving you it through variables like function pointer type, and C++ is giving you through a different syntax that we call inheritance. When we inherit, there are different things that are happening at the memory level, and then through those memory manipulation, function pointer manipulation, by the object-oriented programming compiler, we are just switching the function pointer value. And that's why the concept of delegate, function pointers, and inheritance is so important, that you understand that parent object can invoke child object using the virtual and override keyword. With that said, let's jump to parent implementation, and there is something called as pure abstract class. When you don't want anybody to create an object of this particular class with the new keyword, there are two ways you can do it. You can put the abstract keyword, number one, and you can also put the abstract keyword in front of the function. So when you do that, notice the red squiggly, and it's saying that abstract method cannot be marked as virtual. So I'm going to delete this. And the second error is cannot declare a body because it is marked as abstract. So it is complaining that I don't want this. Right? So now that the error is gone, it is abstract function. Nobody can do new parent, and everybody, any class who is inheriting from the parent class, they will have to implement the log function with the override keyword. Because child2 is not doing that, we are getting a red squiggly here, and then notice that it's saying child2 does not implement inherited abstract member parent.log. And to implement that, it is pretty straightforward. You can come over here, hit control dot, or you can click on this and this bulb. I'm going to hit control dot and click on implement abstract class, and notice that it has provisioned the log function just like this one. So I'm going to copy this line called child2.log. Now I can once again assign this to child2 and invoke p.log, and it is going to print child colon log and child2 colon log. So I'm waiting for the output. So this is the previous run. Alright, it is complaining over here. The compile process did not get through. It does not like creating an object. So we'll have to comment this part out. And now if I hit Control F5, this is what I get. So using the reference of the parent class, we are able to invoke the log function of both the child that it has. Right? This is dynamic polymorphism. It has been present since C programming language. It was done using function pointers. Now it is done using abstract and override and virtual keywords. That. All right. The discussion that we did for virtual and override and abstract, we can apply the same discussion to member variables as well. But then I think it doesn't make as much sense, and I've never tried it. Okay, but then I am pretty sure that it's going to SSS is probably not going to apply to member variables. It is only specific to methods.